So Vasu, welcome to the Energy Summit organized by this Energy Consortium. So I'm an academician and a chemical engineer, and I would like to ask you some questions related to the transition that that world is undergoing from this conventional fossil fuels to the green energy. And one of the key aspects that I understand is that the economics of all the things, all the green transition that has to work out well, or the policies towards the economics, like the balance sheet have to be positive at the end of the day in order for enabling any green transition to happen. Now, my first question to you is, let me start with a simple thing. For any technology to go into the market, what is the economic rule or a suggestion that you would give to any entrepreneurs who want to put out the technology to the market, and even if they might not have a good economic numbers working out now, but there may be a way to work it through. One, it might be a mass production, or it might be through the policies, or it might be through other means. I would like to understand from you, what would be your first suggestion to those entrepreneurs who are working on this green transition, who can think of economics so that their great product or technological outcome can go into the market?
Yeah, thanks, Arvind. Appreciate the invitation to make the presentation and also this opportunity to discuss some of our thoughts. There are a couple of points about economics of any lab to commercialization, lab to commercial path. There are two parts, I would say. One is hard numbers, another is soft numbers, if I may use the term. Let me explain what I mean. Hard numbers are typically, your capex, your cost of, per unit cost, unit economics, input, supply chain, material cost, bill of materials, the various things that, as the technology gets de-risked, you work through that process and you probably do a pilot. A typical POC is just proving the concept. That's really, there's no economics involved in that really, it's just at the lab level. But when you put up your first pilot, typically economics starts showing its head and it has to be treated with respect. But it's still not the full economics, because the difference between a pilot, maybe pilot phase 1, phase 2, depending on the complexity of what you're trying to do, you may go through 2 or 3 steps. To the ultimate commercial product reaching the market, there is still other issues such as the scale. And then there are other softer factors as market uptake and so on and so forth. In fact, these were points that were mentioned, kept repeatedly coming up in the various presentations, keynote speeches and all. This is where the government policy has to step in, because until you scale, you can't bring, that's what, the economies of scale can never be achieved. It's a kind of a very, I'm probably repeating something very well understood. But how do you scale? Because you are so expensive in the beginning. Nobody wants to touch it. So you're like a catch-22. You can never scale because you are so expensive. Only if you scale, you become affordable. That particular technology becomes affordable. This is where the policies and the incentivization and guaranteed market, all these concepts come. In fact, people spoke about it yesterday. So when we look at, as a venture capitalist, as person who, we see whether there are pathways. We are early stage ventures. So we are really not at the scale and at the industry level, but we are at the technology de-risking and at the pilot and the first customer level. We are at the very early stage, but we see whether there is a path, a believable path to the commercialization. If we don't see a believable path, we won't invest, because this is a dead end. So that's the thought process that we go through. The hard numbers, reasonably easy to work out. How much will it cost to build this reactor? How much will it cost to get input, the cost of all the input raw material? What is the market cost of hydrogen that you're going to sell, or maybe carbon that you extract out of, whatever. Then the soft costs, and there is also the risk. There is certain costs that you can never estimate, and typically you kind of put it as a risk. And that also, that's a little bit of a unknown, and it gets more and more understood as the technology matures. So that's the whole kind of a picture that we try and develop as we deal with these things. Yeah.
Thanks, Vasu, for that exciting comment that you have given. But I have a follow-up question on that. So you mentioned that you need to have a clear path, believable path. I like that word, believable path, for any technology to go into the market. But then policy is heavily driven by certain things. For example, if you're working on large things like energy storage or energy conversion or decarbonization, the policy makers typically really do look into it. But not all the innovations are directly related to that. For example, let's take a hydrogen economy. There may be a small component into the whole system that goes into the like electrolyzer or a fuel cell or any other balance of plant that is integrated along with the renewables or integrated to the hydrogen storage and compression. That might not be directly influenced by the policy. But then they may have a clear trajectory. But then the trajectory, if the policy component is already involved in it, then it might look economical. I'm an academician, so for example, we work on a lot of products. My doubt is that at the moment it may be expensive for whatever we are developing. But how do you include that policy component to it when we do this economics is something, if you could help us really understand that, specifically for academicians or students who try to work on piloting their products, this would be really helpful. So without policy, like do you have some sort of buffer or economics? And when we add the policy component, there will be the next level of buffer that you really take into. And then when after subtracting all these things, you get the final economics value. So do you clearly deconvolute between before policy and after policy? And if policy doesn't enable, what happened to those technology? The technology might be really great, but if policy doesn't assist, what will you do with that? If you could help me understand that, this will be, in fact, quite helpful for all the students who work, and Research Park especially, which is a hub for innovation and incubations. Many students, many innovators can benefit from this.
Yeah, thank you. Pretty deep question and thoughtful question. Let me explain. In fact, in some words, I can say there is a world before policy, economic world before policy, and an economic world after policy. But let's first see the word we use, the definition about pilot, right? We talked about pilot, right? Piloting from a POC to the leap to commercial is through the path of pilot. Typically, you need to get some customers who are willing to pilot it. A pilot is the lab to field journey. Goes through a pilot. And when you do a pilot, you are not incorporating, typically you're not incorporating the policy impact on your prices and all that. It's a little bit too early, because the pilot is, can this scale up? Can this process, whether it's chemical or electrical, fluid flow, whatever it is, reaction, this is more on the engineering side. Even on the medical side, these questions can come up. Can it scale up by itself? Is the first question you ask. Because, example, I'm a chemical engineer, and if I talk about a fluid flow, just because I can do some certain, let's say, technical solution with a pipe size of 10 millimeters diameter, and I've designed my POC and I proved my point, maybe even a reactor, a fluidized bed reactor, miniature one and all that, and then I'm suddenly saying, oh, I can run a 10-ton plant. No way, I'm sorry. The moment you change your pipe size and the fluidized bed reactor size, so many factors change. Surface area to volume, and the pipe and the Reynolds flow, and the laminar flow will not be there, turbulent, or the pressures, that everything changes. It's not linear. Until that is proven, the discussion about policies impact is too premature. But the moment you have proven that the scale is possible, the impact of policy the absence of policy will probably be, you have to fight the market out. Inherently, this has to be valuable, but policy may be guided by the greater good. Because remember, every individual or even the governments, we have a dual role always. One, I am an individual, I want to enjoy my life, I want to have a very cushy life, but I'm also a global citizen. I have to act responsibly. It's almost like freedom. Freedom is not absolute freedom. It's a relative freedom. I can't come and do something to you claiming that's my freedom, So it's like that. If my use of energy, I want to have I want to fly, I want to have my own, I don't care about how much my flight, how much carbon I'm putting out. I go by car because it's about convenience, comfort. I want a very, cushy life. And then what about my responsibility as a global citizen? How much harm am I causing? So where do I draw the line, balancing my standard of living and my overall? Same thing, the policies are driven by this combination factors. When if you take lithium ion batteries, they were at 120 kilowatt hour per kilogram, energy density. Today, they are reaching 280, 290. This research and this progress, at 280, 290, they are very attractive commercially, economically. They can do come into a lot of application. But at 120 or even below, before that, 15 years ago, 20 years ago, they were not economical. But because policies continue to support and push with the concept that, EVs, we can avoid point emissions at the, millions of cars emitting all kinds of gases and running around, which is much more difficult to control than a centralized plant. That drove the development. So policies have an impact in helping you scale up, and there is a whole process that you can go through. So think of it as, yes, policies can be either already mature policies, or policies can come and help support build the market.
Yeah, thanks, Vasu. So it's again a follow-up and more curious. I think you're really like tinkering my head and then try to get a lot of thoughts out of like what we do in the lab. So you gave an example of lithium-ion battery. When they were at 120 kilowatt hour per kilogram, they were still far higher than the lead-acid batteries, right? But even then, it wasn't probably commercially attractive for whatever reasons, because maybe the lead-acid battery production capacities are our technology is very mature, industries are very mature. Maybe the lithium-ion couldn't really come out if you stayed at 120 kilowatt hour per kilogram. Now, imagine if you are going any technology which has 3 times increment. Like we're talking about lead acid to lithium ion, early stages, where there were 3 times increment. Still it wasn't really attractive. But then the moment it crossed 200, it has become so attractive. So we are talking about phenomenal technological development that will eventually let the policy makers to really turn around and try to see this is a viable technology. Is my understanding correct first? Is it like we have to do a giant increment in terms of like the performance or specifications, I'll use the word specifications, of any product? Plus, of course, there are other things that you brought in, the global citizen. So let's say there are some places where people talk about less carbon emissions when we use this mode of operation, or less carbon emissions if we go by this kind of food culture, whatever it is. These things are coming into the play. I feel like these two are two distinct things. The second is mostly individual driven, right? Meaning I don't want to contaminate this world. So I try to, instead of using car, I may go by public transport. That will automatically drive some of the technologies. Some of them which are non-carbon emitting might come into the play because a lot of users from this sector will go and start using the less carbon technology. Whereas the other thing that you talked about is a phenomenal technological advancement. So which one typically policy assists more? Is it that human behavior that is tending to move from the older technology to the newer one? Or is it that more technological advanced thing? I've been talking always about going from film cameras to the digital cameras, cathode ray tubes to the like LCD displays, and many things happen. Like many things are transport, the mode at which we transport. A lot of places, industrial transitions have happened, and in almost all the places, the technological advancements are very big. So when you, as a venture capitalist, do you look into marginal increment as an advancement also? Or even if that marginal increment has a plan that if they go forward, they can go even further down, or if they have a clear roadmap, do you think that also has an advantage? Since you said you're an early investor when the technology is at the early stage, what is the kind of increment in performance, or what is the kind of influence or the impact that it's going to make in some sector that you prioritize?
Yeah, thanks, Arvind. So we didn't touch on one factor in the previous point and the discussion about, example, the lithium ion 120 kilowatt hour going to 280 or 300 today, 270 or 280 today, is the cost. Because the cost of lithium ion batteries, when it was 120 kilowatt hour per kilogram, was way more expensive than lead acid, way more expensive. So you have to bring the cost factor in for the market to make decisions. Now today, the cost factor, just like what has happened with solar, wind, per kilowatt hour, how the production value has dropped enormously. Those are all examples where the cost was way too high. The benefits for the global greater good was observed if these technologies became full scale at affordable cost, and the policies paved the way, creating a market, supporting them when they were not viable, and filling up that gap. From today, for example, just as an example, if the power is 6 cents per kilowatt hour, and if solar was costing 12 cents, government was bridging the 6 cents. I'm giving you some numbers, maybe an exaggeration, but they were bridging it in order to encourage, because they knew that if enough scale developed, the solar prices will drop. So in general, a lot of these policies aiming at the global benefits. Of course, scientists and technologies give a guideline saying such a thing is possible. It can't be a completely weird stuff that nobody even believes in, and then you can't make a policy and wait for things to happen. Nothing will happen. Okay, so it's all they're all intertwined. The why a policy becomes implementable, because it was supported by rudimentary technology today with a path that would make it viable. So all these combination of these things, it's almost like a jigsaw puzzle. They all have to fit in. They don't exist in vacuum all by themselves. So that is something the cost we have to consider very key element, and the individuals deciding based on the cost, how much value do I get for the cost I pay. That's the bottom line for individuals. The greater good and other things mostly influenced and driven by policies. And policies have all these levers that they can play with. Okay, I see the individual's cost is way too high. Let me play with the lever of subsidy to balance out the thing until the market can take over. So it's a very exactly. So many parameters interact with each other, and there are experts in these areas who really advise, and people like us are more generalists who are looking at various things. I wouldn't be able to talk about something at a domain expert level, but I understand the interaction of that with everything else. We have a much better understanding of how this whole world will come, whereas the experts will typically go in one or two silos and they will not have a view of the other silos. That is the difference. We are people who bridge the various domains, whether it's a pure economist or a domain specialist, a technologist or a policy maker, or we bridge. That's the way we see ourselves. Yeah.
So, thanks, Vasu. I think the bridge that you mentioned is absolutely essential, I guess. I think the Energy Summit, in fact, really brings in the technologists. And in fact, since you're also part of this whole Energy Consortium and the Energy Summit, I'm sure you also appreciate that the value that we feel when people like you giving a bigger picture to really see where we stand. I mean, we in the sense technologists or engineers, where we stand, it's really immense. Thanks for that great thought. I slightly changed the gear and then go for one more thing, Vasu. So now there are technologies which are available, and there are competing technologies which comes in order to, it can be better, it can be assisted by policy, performance can be better, it can do a larger good. Now, there are some technologies which doesn't exist at all. I'll put it this way, carbon dioxide conversion to value-added fuels. This is one of the key things that entire decarbonization word, wherever it comes from, companies, policy makers. This is in fact top-down approach. In fact, policies come first, then eventually the technology is working out. In these places, if we develop a product for now, because we don't know which technology is going to work out, be it a carbon capture, be it a carbon utilization to generate value-added fuels, or it's just about sequestration, whatever it is. In these cases, how does cost really influence? Because I understand at the end of the day, economics have to work out, because nothing is going to go into the market unless maybe subsidies can last for some time, but then eventually it has to go through. But in these kind of technologies where we don't have any prior benchmark, or we don't have any prior numbers to compare, how will you really make a judgment? That's one question. Next is, PLIs have been announced, like production linked incentives have been announced. My understanding we've been interacting with a lot of companies. Some companies, like especially startups, really feel that PLIs are extremely valuable, which are policy driven, so that a technology can be pushed into the market. But I've also heard PLIs, like for example, very big companies, where they can have a cushion of 5 years to see the return on the investments. So they say that PLIs is not something they would consider upfront in order to see if the technology is going to be in the market for a longer time. So now I'm connecting these two. Like new technologies, like which doesn't exist or which doesn't have a benchmark, like carbon capture, utilization and storage thing. Do you think even there, even before a technology comes out to the market at the piloting level, the PLIs have to be introduced because there is no clear-cut agenda now? Do you think that PLIs will help these two to bridge to promote the technologies to really develop better products so that they may feel value that their products may go into the market sometime, because government is already putting not just a policy to decarbonize but also policy to push the technology to the market?
Yeah, thanks. So, two parts to the question, and let me just answer on the first part clearly. You talked about technologies which don't even exist today, or it's still not. This is where the blue sky research or the academic world comes in, because the beauty of the academic world and research is actually they have to be. I'm going to say something which may sound controversial, but actually, if you think through, it's very well aligned. The blue sky research should be unfettered by any economics. Your job is to show that the science allows that to happen. Then the next step is to see, is it economically feasible? What does the law of thermodynamics say if you got to use CO2 by splitting the C and the O? What's thermodynamics saying? How much is the energy? Minimum energy needed, because maximum energy is inefficiency. I can keep throwing a lot of energy to split CO2. But what is the thermodynamic limit below which you cannot go for splitting CO2? As an example, I'm again taking an arbitrary example, or maybe it's very relevant to this point. Because carbon is very valuable, and then of course oxygen is okay. If you're able to valorize the carbon, now you've started. If you give me a technology that splits CO2, then the next question is, what's the economic aspect? If you tell me that the economic limit, the thermodynamic limit is, Vasu, you cannot go below this, then I do a quick economics and say, price of CO2 is this, price of carbon is that. Thermodynamics limits me. I'm going to lose money every molecule of CO2 I break. Boom, there is no business there. But you tell me the thermodynamic limit is there, and I do a quick calculation at a very high level. The carbon, CO2, what is the price? Whatever it is. Okay, I buy CO2. I apply the theoretical thermodynamic limit. I get so much carbon. That's the market value. Oh, there is the window. There is a gap. I can make money. Then efficiencies and economics and how efficiently you can, everything comes into play. So the physics sets the limits. Physics and chemistry, science sets the limits below which I cannot go.
So just on the point, sorry for the interruption. So you said that we have some data, like some numbers that you have achieved now, but thermodynamics, or you would use the word theoretical. If the theoretical numbers are showing really a big potential, then you would consider looking into the technology. Is that what you mean?
It's even before that, even if no numbers are there today, if your theoretical calculation of the energy needed by thermodynamics to split CO2 is so much, and I do a market calculation of the price of CO2, what's the price of energy I have to put in, what's the carbon I get, I sell it in the market. If that doesn't work out, because you cannot minimize the energy usage there unless CO2 becomes completely free. Okay, even if it becomes free, the cost of the energy that I have to put in. Minimum energy, thermodynamics defines it. I can waste energy and do a terrible job, then my cost is only going to go up. So at the minimum, if my business doesn't, unless the cost of carbon becomes phenomenally high, then so that's what anybody will look at. Okay, so market conditions can change for what didn't seem to be a valuable thing to become valuable. So that is the whole point about the first thing about whether technologies exist. So this is where we love to see obviously being a kind of a engineering background and all that, we love to see the blue sky research and understand, okay, what is it that can be converted to an application, and is that application making economic sense? Is there a market possible? And if it's there is a viable path towards economic feasibility, then other factors can be considered. But coming back to your question on PLI, favored by startups and not favored by large organizations, very quickly, large organizations think ahead. Okay, that's essential for their survival. If they, of course, even though many organizations seem to be behaving as if they're only thinking 3 months ahead for the quarterly result, in general, large organizations think ahead. So it's a very correct question they ask. Hey, what happens if this PLI scheme disappears? What happens after 5 years? This thing is not viable. They're not running this for 5 years and shutting it down. Whereas startups typically just want to get to the market. They're not thinking too far ahead. So they are more excited by the next 5 years because they are struggling to make money. They are struggling to penetrate the market. So if you're selling X and your sales becomes 2X or 5X or 10X, it's an amazing achievement. They're not thinking 5 years and plus, oh, what happens if the PLI disappears? So it's a very natural behavior of startups and large companies.
Great, Vasu. I think this is really cool on how PLI can impact a startup and how PLIs can impact a large industries. Now, I would like to slightly also keep this topic off and go slightly into the more of academic mode, purely academic mode. For example, if you want to advise startups, I'm sure you know what is happening on the government side and then the policy side. And there are some sides which academics probably have to look into. But by our key thinking about curiosity-driven research, we may be working on something. Have you ever thought about there is some policy that is available? If academics do these kind of activities, it can be superficial level, like as you said, in the generic area, like at the top level. This is the area that academics probably have to focus on and try to get, or don't stay in the silo. I think you used the word silo, I'll also take that from you. If you academics really focus on these kind of activities, I'll give one example. Typically, let's say if you want to decarbonize the cement industry. So the thing is that the number of people that have to come in, like who have to come in to really solve that problem is phenomenal. And thing is that sometimes academics have to pitch in, multiple expertise have to pitch in. Similarly, industries have to come in to really assist us on what numbers really make sense. That exactly that you pointed out in the previous discussion. So similarly, have you thought about some of the areas that academics are not looking into? Because this in fact can trigger some of the minds of our PhD students or postdocs who might be thinking to work on those ideas, and also faculty members like me who might be thinking of this idea, but maybe there is a small push that is always required, right? It can be a curiosity, or it can be some sort of sense that, okay, my product may go out to this market. So if you can give an idea, like these are the areas that remain untouched, or probably you guys are thinking, working on something big, but it may not really go big. But then there are areas where you're investing less, investing in the sense our energy and time and resource on developing a blue sky, or working on the blue sky research, which we are not investing much time into it, but they may become really a big value. If you can give some suggestions that may open up new areas of research, specifically targeting the word green and decarbonization. Let's focus on our energy. If you can give some ideas, it will be really great.
Yeah, it's I think probably a tough question at this point. The reason is, as I said, we look at a very vast area, domains and sectors to see what is the interesting action going on. So if you talk about greening and carbonization, a couple of areas where I find very low level of action, and there's a very good reason for it. It's really tough area which demands huge investments. Is, of course, it's been pointed out, steel industry and cement industry, which are two of in the industrial world and even at the global carbon emitting level, it's really for decarbonizing these two industries, or at least making them carbon neutral by capturing the carbon, is a major area. So carbon capture is definitely an area that needs to be looked into. Figure out how, because you can at least project an argument that I'm not able to change the steel industry's use of carbon, but I'm making it net zero by capturing the CO2 in an economical fashion. So capturing CO2 and being able to valorize it is definitely a topic. We know that CO2 is one of the stablest of all gases. So thermodynamics gives you so much headache, and the amount of energy needed it's phenomenal. But I know companies like CCG Plasmonics, which is using solar energy and basically taking the what nature does, CO2 captured as carbon, wood, reducing CO2 and creating wood. That's what all the plant world does. How can we reproduce it? Okay, and they are doing it at basically photosynthesis, but this is really human synthesizing, human created photosynthesis. That's a very interesting area using bio, structures. So they, and if you can figure out plants or ways, and this plant is not the nature plant, but human-made plant that I'm talking about, large scale, which can take CO2 and capture carbon. Either you are emulating nature, that's a great area because you will take a big step towards decarbonization. Today, we can grow big trees and do all that, but that's a process you can't accelerate. You can't make a tree grow enormously fast just like that. You can do all kinds of things, but then that's a thought that I have because the steel and cement industries are tough to abate, as they say. That's the exact terms people use. It's a difficult to abate type of industries because fundamentally the way they use heat and they use carbon and all that is very, and the clinker formation process in cement, it just gets very complex. The other one is heating, building heating. Material science, efficient materials and efficient design of buildings is an area that can make a huge difference. There are a lot of people working on it, so I'm not saying they're not. Whereas in the carbon capture, I know companies working, but as I said in my presentation, today we find 1% of the companies in the startup world is focused on energy. 1% out of, in India it's about 1,000 startups focused on energy out of 110,000 startups. And worldwide it's not, the ratio is not. That's why various companies, were putting energy fund, climate fund, putting billions of dollars to encourage this process. But, I'm talking about fundamental kind of thing, how do I take CO2, trap the carbon, like what I spoke about. That level of science, very few companies are there. So if, as academic person, if you want to pick areas where you want to attack, you may want to look at that level, where what is the science and physics telling us? How do we trap carbon? Yeah.
Thanks, Vasu. I think, in fact, the bio method that you mentioned, I think it's seriously exciting. Like we work about direct air capture, right? I think there's a huge ganga about this specific area. And I've heard like some in chemical engineering, civil engineering at IIT Madras, specifically targeting like the trees or plants which can grow few meters in few months. That can trap, in fact, more carbon dioxide than what we expect. I think we should holistically look at the synthetic as well as the natural one. That is the takeaway message for me and for all the listeners in the system today. And I just wanted to add like two sets of rounds in the last set of questions. One is targeting sustainability, and the last is anything that we have not discussed. Like, let me focus on the sustainability now. The thing is that, let's say if you go to the conventional, since we talked heavily about carbon capture, in the oil world, I'll put it this way. I mean, we all got, every individual in this world got benefited by the oil. At the time, there was no like cost that we have spent after burning the oil, right? I mean, it was just dumped out, right? And nowadays, we are very cautious about the sustainable environment or the health of the planet. Now this adds up to the cost. It doesn't matter. Nowadays, even if you go to the solar panel, if you go to the batteries, the cost of recycling and putting them back into the supply chain loop, either as a material or as a device, really that cost is being added up now, I believe. And the carbon credits, right? Carbon credits will definitely affect the carbon industry, fossil fuel industry, but it may affect to some extent the renewable industry as well. But keeping the carbon credit aside, the word sustainability has a cost involved, which was not a big factor in the past. Almost entire transportation industry never, like all of us are benefited by that, the word, we don't really care about the sustainability. And now that part has come in very seriously. How do you think about that word sustainability now? So should the user really feel that, yes, I owe this cost of sustainability? Maybe there was X cost when I was using my car or whatever transport they've been using it. Now there's going to be delta X improvement due to that sustainability factor involved. If you could help us understand, yes, I would like to add that, like as an investor, do you feel that delta X can be increased in order to keep this world sustainable? At the end of the day, planet is absolutely important than the small delta X increment. That's the way I think about it. But then in terms of economics, how do you think about it, Vasu?
Yeah, thank you. Now because sustainability is about the greater good, so there is this immediate conflict that comes between me as an individual who wants to, enjoy all the pleasures of life and not worry about paying the price. And sustainability tells you that, hey, you better wake up and there's a price for everything we do. And, you're right in pointing out all the historical things and, solar, wind. There is also a price to pay for that also, because yesterday people were talking about wind turbine blades. What are you going to do with them? They're going to be filling up junk, all this stuff. So, there are many mechanisms people are working out.
Just a quick thing, Vasu. We may have paid indirect consequences of that. Maybe, do you think that indirect consequences also had economic consequences when we are using transport? Maybe that probably we already account upfront when the word sustainability is on our mind, and the delta X we pay for the sustainability. If you could help us understand that part, it would be great.
It's just my view, and it may not reflect all angles. This is a very deep topic that the whole world is discussing. But I believe that there's a certain level of philosophy also has to be brought in here. Because if you demand more and more and more and you are using, there is effect. There's a side effect. You can call it wastage of energy, then that's entropy. But inefficiencies, all those aspects do play a role. Have they been quantified? Not very much. If you take one small example of that, carbon footprint calculation, okay, it plays a big part in sustainability. It's a big topic all over the world. Talk about scope 1, scope 2, scope 3. People are trying to calculate everything. Scope 1 and 2 are slowly becoming clear in most of the major industries and most of the major big activities. But scope 3 is a very complex, deep, it's like a very complex maze of a burrow system, because when scope 3 is what my suppliers, basically it's my supplier's carbon footprint. Now if I go to my supplier and say, give me your carbon footprint, they are pretty clear about their scope 1, scope 2, but their scope 3 is their supplier's footprint. So you start going down, then you say, okay, I have to, I'm buying this equipment from the supplier, and so you go to the supplier and say, I want the carbon footprint of this equipment. Supplier looks, okay, I buy all these raw materials, this steel plates and this motor and this and that and all that, and this is my scope 1, scope 2. Scope 3, I have to ask those suppliers. So you go down to that, it's a nested process. So you go to that steel plate maker and the motor maker, he will say, copper winding, I have to ask my supplier. And the steel plate, because they are clear on their scope 1, scope 2, but they have a scope 3. So the scope 3 will lead you to the mining of the ore. And by the time you get to the mining of the ore, then you ask the question, wait a minute, how did I mine? I used Caterpillar, huge giant machines. What about their scope 1, 2, 3? So you will literally end back to the pre-industrial revolution starting point. Now this sounds like a crazy debate, but this, from a factual perspective, this is true. So people will make theoretical assumptions and stop at some point, because it gets impractical to start saying, okay, I'm going to go to the ore and mining company, and the mining company is using Caterpillar, and then you go back to the Caterpillar. So he has machines and it's like you're in a perpetual catch-22 cycle. You will never get out of it until you go to the pre-industrial era, when you could use that as a starting point for carbon footprint as your reference, and then everything else. In fact, that is the reality. That is the reality, but we can't face that complexity because it's just too much headache. Your brain will frizzle out. So you make some assumptions and you stop at some point. That's where the world is. So scope 3 is a big topic in the world, especially for industries today. Scope 1, scope 2, industries are beginning to get some handle on it. There's a long way to go. But the small and medium businesses have no clue on scope 1, scope 2. So they are also going through the process. So this is the kind of sustainability where the kind of, this purely from a carbon footprint. In some ways, this is about global warming aspect of it. But if you talk about energy aspect, it's much more complex. Energy is beyond carbon. Let's be very clear, okay? This is, carbon is definitely the GHG, all those things that are happening in the world. Yes, we are talking about climate, global warming, all that. But energy is something way beyond that. Energy, we are, in fact, my final slide when I presented this morning presented the 1972 paper, which basically said there is a physics limit on the energy that we will be able to use for economic growth. In other words, economic growth is not continuously exponential. It is a S curve. It's a sigmoid curve. It will flatten out because the earth, ultimately all energy we use, where does it come from? The sun. Everything, it doesn't matter, even the volcanic activity, even the so-called nuclear activity of the earth, everything. At the end of the day, the nuclear activity doesn't come directly from the sun, but if you take the overall picture, there is a limit to how much energy the earth itself has and how much we are receiving on a daily basis. So if we need more energy than what we receive from the sun, which can support only so much per capita energy usage based on the billions of people we are going to have and the standard of living, I want more and more energy footprint, all those kind of things. We can do a calculation. It's not a big complex math. You can do a first order approximation. If you need more additional energy than what the sun provides on a daily basis, then you need to try to draw energy from the bowels of the earth, because there is heat trapped or molten this thing and radioactivity, nuclear activity, everything. At some point it's all finite. That's the point its messages. So indefinite economic growth is not possible. So sustainability is not only a notion in terms of just numbers and scope 1, 2, 3 and calculating carbon footprint and all that. It is about, are we able to recycle as much as possible either the molecules or the electrons? I'm using electrons as kind of an analogy for energy. If you can not waste these things and recycle again and again and again, and there is always some, entropy is thermodynamics law again, you cannot get out of it, but you minimize that. That's all we can do. This is the way it is going to be. Yes, is the world sustainable in 50 years, 100 years? Only future will answer. So if we get more reasonable, we will be able to prolong our human existence much longer. Otherwise, we will finish the human existence much faster.
So Vasu, this is honestly one of the best answers I've got in the whole discussion. Thinking is that it's not just about technology development or business, it's about the whole existence itself, You really touched upon a great point. Existence is absolute, and I think we should that is where the sustainability, the word comes into the play. I think if all of us as a technologist, as a human being, I think we shouldn't even go to the word technologist or economist or a venture capitalist, whatever. As a human being, if you look at it, I think the word sustainable or sustainability makes a lot of sense, and I take as a conclusion that I would definitely pay that, possibly the delta X that I mentioned, in order to keep this world more sustainable, because it's about existential threat that you're talking about, existential threat, right? And it's going to really encourage students, early innovators, and in fact the people from the innovation side who are going to go to the startups, and academia, and in fact even industries, like all of them are going to benefit completely. And specifically some of the nice areas that you pointed out, which we probably are ignoring or we are not looking into, specifically the biotype of area that you mentioned. We are seriously going to step onto that, and we try to bring in necessary stakeholders from all domains, starting from academia to the industries, and we will definitely work on that. With that, I would like to thank you so much for spending your valuable time discussing your thoughts during this Energy Summit 2022. Thanks so much, Vasu.
Thank you, Arvind, and thanks for this discussion. I hope my answers were relevant and answered your questions. And I want to thank the organizers, even though I'm one of them. But I think that very well organized, great, and let's hope that we go from one height to further heights, greater and greater heights, and greater success. All the best.